Okay, good day everyone. Okay, good day year 13s. Good day. Okay, this video session help us with uh, partial fraction type 4. Okay, partial fraction type 4. Okay, if we go to a Moodle or notes, partial fraction type 4. We've done type 1, 2, 3. Okay, so this day we'll be doing type 4. Okay, so is uh, type 4 is denominator with repeated quadratic factors. Okay, denominator with repeated quadratic factors. Okay, just for recap. Okay, on our notes. Okay, so type 1. Okay, partial fractions. We deal with type 1. Type 1 is denominators with linear factors. Okay, that is type 1. Okay, type 1 with linear factors. Okay, with linear factors. Okay, in partial fractions, when we deal with partial fractions, we look at the denominator. So denominators with linear factors. So, okay, linear factors are equations or factors that have x raised to the power of only 1. Okay, so it could be x, or it could be x plus 1 in the denominator, or x plus 2, and so forth. Okay, all the x's are raised to the power of 1. Okay, so 2, we have linear factors, repeated linear factors. So repeated linear factors. Okay, repeated linear factors is factors of a linear that is repeated. How is it repeated? For example, if we have a linear of x plus 1, okay, when we say it is repeated, it raised to the power of 2 or raised to the power of 3. Okay, and 3 is denominators with quadratic factors. These are equations where we have x is raised to the power of 2, okay, or equations where we have x raised to the power of 2, okay, like what we have here. Okay, these are quadratics. Quadratics are equations raised to the power of 2. Okay, I hope we get that. Okay, now moving on to type 4. Type 4 is denominator with repeated quadratic factors. Okay, so for now, type 3 we say quadratic factors. Type 4, okay, is repeated quadratic factors. How is a quadratic factor repeated? Okay, it will have a form of a quadratic, but when we say it is repeated, it will be raised to the power of 2, 3, or 4, repeated 2 times, repeated 3 times, and so forth. Okay, okay, good. Okay, now moving on. Now to for type 4, when we are dealing with repeated quadratic factors, we do the same as type 2, where we have repeated linear factors. Okay, for example, having 2x plus x as our example on our note, over x squared plus 1, like that, raised to the power of 2. Okay, this 2 indicates that that particular quadratic equation, x squared plus 2, is repeated 2 times. How it is repeated 2 times? Okay, if you rewrite it in simple terms, it will be 2x plus x is over x squared plus 1. Okay, over x squared plus 1. Okay, that particular equation x squared plus 1 is repeated 2 times. therefore it will be written as this. Now, what form does it take? Okay, since this is a factor of a quadratic and this is a factor of a quadratic, it will form under the form, okay, remember the form of a quadratic is ax plus b over whatever quadratic it is given. Okay, okay, this one. Okay, so if you notice here, this is a quadratic equation. So from our note, then it will have a quadratic form here. Okay, again, you have another quadratic, then you will have another quadratic form here. Okay, so like type 2, it will be since it is repeated 2 times, it will take this form of a plus b, ax plus b over, since it is a x square, it will start off with 1, x squared plus 1 is the power 1 plus c x plus d over x squared plus 1 square. Okay, so this is what we have in our note here. Okay, so after we have this, then we follow the same procedure as we normally do in type 1, 2, and 3. We choose either we use a coefficient method or substitution. Like for this section here, like I mentioned to my class that when we're dealing with partial fraction, when it comes to type 4 and type 3, when we're dealing with quadratic denominators, what we do is we use the method of equating coefficient, which is much more sufficient to use because it helps us to find A, B, C, and D. Where substitution method in quadratic denominators, it's difficult for us to find that. Okay, so when we're dealing with only linear factors in a denominator, it's best to use substitution method. Okay, so here what we do is we use equating coefficient. Okay, so we find the denominator, common denominator, and we find the numerator like we normally do. Okay, then we get this. Okay, this is the extraction of only the numerator. We forgot about the denominator. Okay, so we only take the numerator here, then we expand the brackets here. There you go. After we expand the brackets, then we group the like terms, ax cubed together, x squared together, x's together, and those without x's together, and then we factorize if necessary. Okay, so ax cubed by itself, x squared it's by itself. We have ax plus bx, taking this x outside, we have a plus c, x outside, and b plus d. After that, we collect like terms. Now we equate coefficient. Okay, so the number in front of the letter x cubed here is a, and the left hand side, the number in front of the x cubed here is, there's no x cubed, so it is 0. Okay, the number in front of x squared is b, the number in front of x squared on the left hand side here is 2. There we go. And the number in front of x is 1. Number in front of x here is a plus c, so a plus c equals to 1. Okay, and then you have p plus d. P plus d, what is the constant here? P plus d equals to 0. Okay, so from our equating coefficient, we already found a, which is 0. We found b, which is 2. And then to find c, we substitute 0 into this equation here, where a is, okay, and you get c. So you have 0 plus c equals to 1. C equals to 1. So you know a, b, and c. Okay, and that's it. And then you substitute back into your form. Okay, I hope this session helps us with type 4. Okay, if you have any question, you can message me. Okay, you can message me or put a message on Moodle chat. Okay, okay. I think that's it. Thank you, year 13s. You have your exercise there. Please do those exercises. Always remember when we're doing partial fraction, first thing we do is we check if it is bottom heavy. Then we check if it is the denominator is factorized. Okay, those things. Please remember the basics as we learned in type 1. Okay, thank you everyone. You have a nice day and hope to see your questions online. Okay, thank you. You have a nice day.